Hey guys, this is lecture video 7 of CSE2000Q2S Computer Science 2, taught by Lawrence Orijuela, and my name is Lawrence Orijuela. Today is October 16th, 2020. Today we're going to talk about structs and classes, and we're going to finish our discussion of structs and classes with this discussion of constructors. Okay? Now, before we actually get into this, I just wanted to share something with you. So, as you all already know, I'm a computer science master's student, and in case you didn't know, one of the requirements for graduation for your master's degree is a master's project. Okay, that's where you work alongside professors, like CSE professors and your CSE advisor, to work on a project that's computer science related that will contribute to, I guess, an advance in the field, per se. Alright, so in case you guys want to know the project that I'm working on, so I'm currently working with my advisor on this master's project that involves applications of machine learning and AI to render images of the hearts undergoing radiotherapy. So it's not just computer science when it comes to this master's project. It's also this also dives into the medical field. So not only am I brushing up on my Python, and because I believe I'm going to have to use the TensorFlow library in order to work on this project, but I'm also reading research papers in regards to the hearts and radiosurgery, atrial fibrillation, things like that, heart disease, heart attacks, and I'm gonna learn all of these terms and all the technology and all the technical jargon that doctors use, and it's actually it's exciting, but it's intimidating too. So yeah, my time right now has been consumed by not only my project but also my other master's classes, as well as teaching this class. Well, I know you guys don't care, but I just thought I'd share that with you. Okay. Anyways, back to business. Constructors. So here is our tentative schedule once again. We made one change to this tentative schedule, that being we moved the due date of your midterm exam from October 16th to October 23rd. Okay? Because that was what we agreed upon in our last Zoom meeting. Okay? So, that being said, you don't have anything due tonight, but you will have 2 items due next week, that being your Activity 6 and your midterm exam. Okay? So, a couple of remarks on the midterm exam. So, as agreed upon, you have an extra week. I already discussed that. It'll be due midnight of October 23rd. You're welcome. Now, these questions, you probably already noticed this because you've been on this for a week already. The questions are almost exactly the same as the practice midterm. So, please watch the video solving the practice midterm questions, and then you'll realize how easy this test is. And as always, please submit this midterm the same way we've been submitting every other assignment, and that's by email. Because, truth be told, I hate Blackboard. I've been fooling around with Blackboard trying to get used to its features, and I just decided it would be much easier if all my students just emailed their material to me. So anyways, constructors, let's get down to it. Well, it would be useful if we reopened our lecture activity 6 and did a brief recap of everything that we did before we continue. So I'm going to go find the place where you saved your lecture activity 6 and open it. Okay. So we have, if this thing will load. So here's everything we did so far. So we created a struct called store item that contains 3 member variables. And then we declared 3 instances of that struct. Okay? And then we pushed them to a vector of store items. Okay? The second thing we did was we created a class called person type, which contains 3 private variables called first name, last name, and age. And then we created 3 instances of that class and then used our setter functions to initialize the private members, okay? And then we pushed everything to a vector of person types. And then here are just some user-defined functions that printed everything. That's all. So, yeah, so that's everything that we did 2 weeks ago. It's good to brush up on it since 2 weeks is a long time. And not only that, you also got your midterm on your mind too. So, yeah, I just thought I'd brush up on everything we did last week. So, that being said, all right. So, constructors. What are constructors and what are they used for? So, consider this. Classes and structs contain member variables. When a new instance of an object, and when I use the term object from this point on, I'm going to use that to refer to structs and classes, okay? When a new instance of an object is declared, the members aren't initialized. A constructor is a member function of a struct or a class. Its purpose is to automatically initialize the member variables when a new object is declared, okay? And then here are a little side notes about constructors. So structs and classes can have multiple constructors, useful. And then the other one, how the member variables are initialized depends on how we code our constructor functions, okay? So this is what I'm talking about when I say declaring and initializing, okay? So here are some screenshots of the code that we wrote last week, okay? So if you look over here on our struct code, on line 21, we created a variable of type store item called item1. Line 21 declares a new variable. Lines 22, 23, and 24 initializes the member variables of that struct, the one that we declared, okay? All in all, this took 4 lines of code. You see that? And if you look over here to the right, we did something similar, just with classes. You know? If you look here, on line 49, we declared a new variable called person A that's of type person type. And then we used person A's setter functions to set first name equal to Jane, last name equal to Doe, and age to 25. This also took 4 lines of code, okay? Now, to change the member variables of a struct, we use the dot operator. To change the variables of a class, we use the setter functions, okay? But over time, doing it this way gets tedious. Like it wasn't so bad this time because our struct had 3 variables and our class had 3 variables. But what if we write a struct that has 10 or 100 variables? The same thing with classes. What if we had a class that had 10 or 100 variables? Like, we don't want to write a line of code for each to initialize each member variable, do we? Because that would take up a lot of space, right? This is what constructors are used for. Imagine having a function that declares and initializes each member variable all in one line. That sounds useful, right? It would save you a lot of time. So yeah, that's the main purpose of constructors, to make things easier for us to write. Okay. So moving on. So constructors are simply member functions and are treated as such. The parameters passed to a constructor are the values that we set the member variables equal to. And it is good programming practice to write a default constructor first. And a default constructor is a constructor that accepts no parameters. And then we would just use lines of code to initialize each individual member variable. This will make more sense when we demonstrate it. And then after we write the default constructor, then we write the various other constructors that have parameters passed to them. And another note, constructors can be written for both structs and classes. The only difference is the syntax. It's slightly different for both. Okay. So this next slide refers to this next slide shows the syntax for constructors for structs. Okay. Now, because structs and classes can have multiple constructors, because we're going to have one default constructor and multiple parameter constructors, which constructor is invoked whenever a new object is declared? Whichever constructor is used, it completely depends on what parameters are passed to it, okay? Now, the parameter list, so we have the default constructor. Inside parentheses, there's no parameters because the default constructor is supposed to take no parameters. But then the constructor with parameters, just a parameter list here. And that's actually the only difference between these two, okay? Now, the parameter list can initialize all, some, or none of the member variables. The remaining member variables that aren't initialized must be initialized to something else in the statements. And I have a section called statements here and a section called statements here. Okay? So with the syntax in mind, we can actually get down to finishing our lecture activity 6 so that you can submit it. Okay? So the syntax is right here. So last week we created a struct called store item containing member variables item name, quantity, and price, which were of string, int, and double respectively. Okay? So lecture activity 6 part E, because we did A through D before, and now we're going to continue off with part E. Write a default constructor that initializes each member to empty string, 0, and 0 respectively. Okay? Now, that makes sense because the default constructor is not supposed to take any parameters, right? It'll just set the member variables whatever we want it to, and in this situation, we want it to be empty string, 0, and 0 respectively. Okay? And then declare a new struct that invokes the new default constructor. Okay? So let's go back to Visual Studio and get started on this. So let's run this thing again just to see how it looked before. Okay, so it looked like this, right? Just declare structs and push them to a vector. Declare some classes, put them to a vector. However, this much space here, I realize that's going to bug me. Let's see if I can fix that. So maybe I can get rid of this. Get rid of an end line on line 46. How will that look now? And that's a little better. Let's actually delete both end lines. Save that. Okay, that's a little easier on the eyes. So, it looks to me like we're gonna make a new section called E, because we have A, B, C, D. Let's declare a new area called E on the bottom. Let's end a line here, cout, end line. And in this new section, we're going to say cout. This will be part E. And it's called default constructor for a struct. Okay? Well, struct default constructor. Okay, great. Now, in order for us to do this, we actually have to write the default constructor in our struct definition, okay? Now, as you recall, structs, the same as classes, can contain member variables. As a matter of fact, I'll put a comment here called member variables. But they can also contain member functions. Member functions. Okay. And the main member function that we use for structs is the constructor, because constructors are functions, okay? Now, if you go back to the PowerPoint, the syntax for default constructor for struct is right here. All you got to do is say the struct name, have empty parentheses, and then in squiggly brackets, you have some statements, okay? And so we want to set item name, quantity, and price to empty string 0 and 0 respectively. That's exactly what we'll do, okay? So over here, we're gonna, actually I'm gonna put a colon here, and then I'll put another thing here that says default constructor, so that it's easy to remember what they are, okay? So I'm gonna use my syntax, store item, open parentheses, close parentheses. And then in squiggly brackets, I'm going to have some statements. Now, do you notice that this parentheses is empty? That's because, as I said before, the default constructor accepts no parameters. Okay? So here's what we're going to do with this constructor. So when we declare store item, if we didn't have a default constructor, what would happen as a result is that when we initialize something, its member variables would be set to gobbledygook. That was because every variable is assigned an address in memory. That address in memory could have contained data for when it was being used for something else. And that's why when we cout uninitialized variables, they have residual data for when they were used for something else, and that's why they contain gobbledygook, okay? But we don't want our variables to contain gobbledygook. That's dangerous if we use them, so we're going to initialize them. So we're going to set item name equal to empty string, okay? We're going to set quantity equal to 0, and we're going to set price equal to 0, okay? Here is my default constructor. It's ready to use, okay? So I'm going to save this, and I'm going to declare a new item of store item. Now, I declared items before. I called them item 1, item 2, item 3. Let's call this item 4 now, okay? So store item 4. This declares a variable named store item that's of type store item. Now, let's see what happens if I cout its individual contents, okay? So I will cout item 4's item name, and then item 4 dot item name, end line. And then I'll repeat this same line of code for quantity and price. So here and here, change this to quantity, change this to quantity, change this to price, and then change this to price. Okay. So because I declared this, but I didn't initialize its variables, what happened as a result is that because the compiler didn't know what to set the member variables equal to, it went back to the struct definition. Like when the compiler reaches line 85, this went back to the struct definition and tried to see if there were any constructors present. And there actually is a constructor. It's the default constructor we made. So because we didn't pass parameters to it, the compiler automatically called this constructor and set item name equal to blank, quantity equal to 0, and price equal to 0. Okay? So if I actually ran this, we should see nothing 0, 0. Okay? Yep. Empty string 0, 0. Okay? Now, try to imagine what would happen if we didn't have this constructor present. Like, if I decided to comment this out, what would happen if I use these lines of code again? Let's see. Yep. The variables, the memory addresses that were assigned to these variables, they contain residual data from when they were used in the previous operation. So right now they contain gobbledygook, okay? That's what constructors are used for, okay? Well, specifically the default constructor. So I'm actually gonna uncomment this out again, and you'll see, yeah. So I guess the correct way of thinking of a constructor is like a safety, so that you're not working with uninitialized variables. So yeah, that's what a constructor is used for. And what else are we going to do here? Declare a new struct that invokes the new default constructor. Yeah, we did that already. Okay, so yeah, this was part E. So we completed this part of the lecture activity. Now it's time to do part F. So now write a constructor that accepts a string, an int, and a double, and initializes the member variables to each one respectively. Okay? And then declare a new struct that invokes the new constructor. So the syntax for struct constructor with parameters is here. It's exactly the same as this. The only difference is that there's a parameter list now that we have to account for. Okay. So I believe what we're going to do is put another section here and call it part F. So cout, this is part F, struct, I guess we can call this constructor or actually, let's call it other constructors. Other constructors. And I'm going to put the S in parentheses, right? And then end line. Okay. So, this is a brand new constructor that we're adding in addition to the constructor that we already made. This is a new constructor that accepts parameters, okay? So I'm going to add another comment here. I'm going to call this constructor for all three variables. Yeah, I think that's okay. So here's what I'm going to do. I'm going to say, going off of the syntax, I'm going to say the struct name again, and then I'm going to have a parameters list, okay? So store item, I'm going to have a string. Let's call it S, okay? With variables, we can name them whatever we want, but when it comes to functions, you want to keep them brief, right? And we're going to have an int called, let's call it I, and we're going to have a double. Let's just call it D, okay? So what this constructor will do, it will take the string S and set item name equal to S, okay? So item name equals S, okay? Then we gotta set quantity equal to our int I. Quantity equals I. And then lastly, we're gonna set price equal to D. So price equals D. And that's it. So now this struct contains two constructors now. One is a default constructor, and which is a constructor that accepts no parameters. The other one is a constructor that accepts and initializes all three variables: string, int, and double, okay? And this is what I'm talking about when I say that structs and classes can have multiple constructors, okay? So since this is ready to use now, I'm going to save this. And now we can continue with part F, okay? So let's declare a new variable of type store item. So I'll call it store item. We used 1 through 4 already, so let's call this item 5. Okay. Now, in order to invoke this constructor, what we have to do is after the variable name, we have to have parentheses, and we're gonna, because this is a function, remember constructors are functions, and we have to pass a string, an int, and a double to it, and they will be set to item name, quantity, and price respectively, okay? So let's think about what kind of new item we want to create. We already had shirt, pants, and shoes. Try to think of another item that a souvenir store would sell. I don't know. Maybe socks or something, or a hat. Yeah, let's go with hat. Okay. So let's go back here. I need 3 variables. The first one has to be a string, and I'm gonna call it hat. The next variable is a quantity. So how many hats is this store selling? Maybe they have 15 hats in stock. And then the price, it has to be a double. How much money would you pay for a hat? I don't know. $12 maybe? Like that. Okay. So, so with this, let's repeat similar lines of code that we did for item 4 and see out item 5's individual member variables, okay? So save this, copy these 3 lines, put them here, change it to 5, 5, 5, change this to 5, 5, 5. Okay. Now, what we should see as a result is that item 5.item name will be equal to hat, quantity will be equal to 15, and then price will be equal to 12. Okay. Let's see if it worked. Yep. So item name item 5's item name is hat. We have 15 of them, and they're being sold for $12 each. Okay? So, one thing that I'd like you to do is kind of take a moment to think about how this struct is working, okay? So, when we declared, on line 93, when we declared item 4, because there was no parentheses with parameters passed to it, what happened as a result is that the compiler jumped to the definition of the struct and looked for a constructor that accepts no parameters, because on line 93, item 4 is declared with no parameters, okay? So we set the variables equal to empty string 0 and 0 respectively, okay? So this is the constructor that is invoked on line 93, okay? Now, consider line 99. This time we did have parameters. We had hat, 15, and 12, okay? So what happened as a result is that on line 99, the compiler jumped to the struct definition, and it tried to look for a constructor that has those variables in it, string, then an int, then a double. And it looked, and it did find one. So it enacted this code here and set s equal, item name equal to s, quantity equal to I, and price equal to d. Okay? So now you understand what a constructor is, and you understand why it's important to... Well, I hope you understand why it's important to have multiple constructors. Consider a situation in which... I know this is an odd situation, but let's say you have variables for a store item already. You already know what the store item name is. Maybe it's socks. And then you have a quantity of 0, but or something, some number. But you don't know what the price is, right? Could you do something like this? Like a store item 6. I'm gonna have socks, and then a quantity, maybe 8, and then just finish it off here. Like, say I didn't have a price. I'm gonna decide what the price is later. The truth is, I actually can't do this, where it's just string and int. Well, actually, I can do this if I made a constructor for it. But right now, there's only 2 constructors. One that accepts no parameters, and one that accepts string, int, and double. I don't have a constructor that accepts string and an int, but I could write one if I wanted to. Does that make sense? Like, if I really wanted to, I could make a new constructor, just for the sake of this. Like, constructor for just item name and quantity, and then just have this again, put it here, remove this, but I can't have price equal to nothing, so maybe I'll just set it equal to 0. And having this constructor here means that I'm allowed to have this line now. As a matter of fact, if I did this and changed 5 to 6, six. What should happen as a result is that item name will be equal to socks, quantity will be equal to 8, and then because this constructor is being used, well, being invoked, price will be set equal to 0. We can see that in action here. Yeah. Now, I know that this isn't part of the lecture activity, but the only reason I wrote this is because I wanted to illustrate that to you, that it's good programming practice to have multiple constructors for multiple instances, especially if you're working together with other programmers and they're not quite sure how to use the code that you wrote. That's why. So, but here's the thing. Now that we we wrote constructors and we know how to use them, there's something that I would like you to do. Because we have constructors now, and because these lines of code are wasteful, here's what I want you to do. For store item 1, comment these out, and then just write one line that initializes store item 1, and then declares each member variable, each one, all in just one line of code. So you know how to do this. So store item item 1, and in parentheses we'll have the string shirts, the int 20, and then the double 10. So as you can see, this one line of code here can take the place of these 4 lines of code. That is the power of a constructor. Okay? So with that, I can actually delete this now. And yes, I want you to delete that for the sake of your lecture activity. And repeat this thing for item 2 and 3. Okay? So store item 2 pants 25 and 15. And now that we have this, we can delete these. And then repeat the same thing for item 3. Store item 3 parentheses shoes 30/20. So delete this because you don't need that anymore. As a matter of fact, this should be item 3, not items. My bad. And then to make it look even neater, let's just delete these comments and then just put all these in one block. How simple is that, right? So I just, with the help of constructors, I actually minimized this code, okay? And we are going to do the exact same thing we did with the struct and do it for the classes, okay? Well, for the one class, right? How are we in recording time so far? We're at... I have a feeling that this is going to be another extra long video, but that's okay. You guys are learning. You know what a constructor is now. And if you want me to, I'll zoom out and you can get a good look at everything. Okay. So now it's time to write the constructors for the class person type. Now, it's really important that I know I said this 2 weeks ago, but it's very important that when we write our person type class, we're on week 8 right now, okay? And we are going to write the constructors for person type.h, okay? It's really important that you get person type, student type, and faculty type.h correct so that you can add them to your lab 3. Okay, so just keep that in mind when we're typing this code. We got to make sure that our code is correct. Okay, but we're ready to do the next part of the lecture activity. These we already did. Let's do this. Okay, so this is the same text that I wrote last time for the structs, but here's the syntax for the class default constructor and the syntax for the class constructor with parameters. As you can see, just like for the structs, they're the exact same thing, except we have a parameter list involved, right? Now, another big difference between structs and classes is that when we were writing a class before, what we were doing was that we put the function prototypes under public, and then we put the function definitions on the bottom, and then put the class name : in front of the function name. And if you look closely, that's exactly what we have to do again, because remember, constructors are just functions, right? And when it comes to functions for classes, we have to put class name : in front of the function name, okay? But the function name in this case is just the class name again, okay? So we actually say class name : class name. Don't let that trip you up. The second class name is just the construct. It just indicates the fact that it's a constructor, and the first class name indicates that this constructor is a member of the class. Okay? But enough talk. Let's get into this. And as you can see, this is the last slide. So as soon as we're finished with lecture activity parts G, H, and I, this lecture activity will be ready to turn in. Okay? Yeah, I know it's this is a very long-winded lecture activity, but I did say before that classes are hefty. If you recall, we're gonna spend 4 weeks talking about classes. Like it's big and bulky, but they're super powerful if you know how to use them right, okay? But anyways, back to here. We gotta continue. So, syntax is right here. Lecture activity 6 part G. Write a default constructor that initializes. Well, first let me read this. So last week we created a class called personType containing member variables first name, last name, and age. Okay? Write a default constructor that initializes first name to empty string, last name to empty string, and age to -1. Okay? I chose -1 arbitrarily. I just said that to indicate to the user that it needs to be set to something else before you can use it, right? Okay, and then declare a new struct that invokes the default constructor. Okay, so going back to Visual Studio, we have to put the function prototype here and the definition on the bottom, and it's very important that we keep them in the same order. Okay. Now, if you go back to the PowerPoint, the syntax for a class default constructor is here. So here is the one for the prototype. Here's the one for the here's the one for the definition. So I'm actually gonna do it like this. So over here in our class personType, let's put a comment right here that says constructors. Okay. The first one is going to be our default constructor. And keep in mind, this is just a function prototype. So the function prototype is just class name, parentheses with nothing in it, okay? So we're going to say personType, open close parentheses, and that's it. Okay? So now we have to scroll to the bottom and create the the constructor definition for it. Now, if you go back to the PowerPoint, the syntax is right here. We gotta say class name, colon, colon, class name, parentheses, and then some statements, okay? So, over here, I'm gonna type person type, colon, colon, person type, open close parentheses, and then in squiggly brackets, I have some statements. So, make a slight change to this lecture activity. Instead of empty string, it's actually supposed to be n/a for not available, and then n/a for not available. So I'm gonna set. So what this constructor does is set first name equal to the string n/a, last name equal to string n/a, age equal to -1. Okay. So this function prototype refers to this constructor. Okay. Now, moving on. Then declare a new. You can see that I like to copy paste to save time. This should actually say class. My bad. Okay. Then declare a new class that invokes the new default constructor. Okay. So save this. Go back over here. This is a brand new section called G. So cout G, a class default constructor like that. So speaking functionality wise, the purpose for constructors for a class is the same as the purpose of constructors for a struct. So I don't think I need to repeat what would happen if you didn't have a default constructor and you just declared the new person and just couted uninitialized variables, okay? Because you already know. So let's declare a new person type and call it person D. So there's a new variable of type person type. We're going to call it person D, and no parentheses, no variables passed to it. So when line 104 is executed, the compiler will go to the definition of person type and look for a default constructor that accepts no parameters. And thankfully, one exists because we wrote it already. And it'll set first name equal to NA, last name to NA, age to -1. Now, it's kind of weird that, admittedly, it's kind of weird that you have a class variable of type a person and you set their first name equal to NA, last name NA, age -1. But doing it like this is better than not initializing it. Does that make sense? So let's see out person D's individual private variables. Okay, so I have to say cout person D dot. Now, because I said this before, because first name, last name, and age are private variables, I can't access them directly with the dot operator. I would have to use the getter functions. So I'm going to say get first name. And I have to put parentheses there because get first name is a function, right? And line. And I should do it the same way I did it, like this. So actually, in this part here, let's say person D's first name. Like that, right? Let's repeat the same structure for last name and age. So copy that, paste it twice, change this to last name, change this to last name, and then change this to age, change this to age. Great. So line 104 invokes the default constructor, and first name and last name and age will be set equal to these. And to prove that to you, we'll save this and run this. Okay. Yep. So person D's first name is NA, person D's last name is NA, person D's age is -1. Now, as I said before, it's kind of weird doing it this way, but it's better than having uninitialized variables. As a matter of fact, if I commented out the constructor like that, and I commented out the prototype for the constructor, what you'd see as a result of this is the same thing that we saw last time. We'll see gobbledygook, right? Yep. It's weird. So, yeah. Very important to keep these constructors. I'm going to uncomment this. I'm going to uncomment this. Cool. So, this was lecture activity part G. Okay? And that was the default constructor. Okay? As always, it's good programming practice to write the default constructor first, then write the other various constructors. Okay, and that's exactly what we did. So now it's time to write a constructor that initializes everything. Okay, so now write a constructor that accepts a string, and an int, and initializes the member variables to each one respectively. Then declare a new class that invokes the new constructor. Okay, so it's actually going to be very similar to. Why is this still? Oh, there we go. It took a while for Visual Studio to pick that up. But anyways, so that's the default constructor. I'm going to put another comment here. Call it other constructors. Okay? So this new constructor is going to accept a string, and an int. Okay? String, int. And as with the function prototypes, you actually don't need to put the name of the variables. Okay? So here's what I'm going to do. I'm going to copy this. Okay? Go to the bottom and make this a new constructor. So I need person type : person type again, right? So I'll copy this, put it here. In the function definition, I have to delete the semicolon, put squiggly brackets, and in the definition, I actually do have to have names. Now I have two strings. I guess I'll name them S1 and S2, just to be consistent. S1, S2, and the int, I guess I'll just call it I. You know? So I'm going to do the same thing that I did here, okay? Except change these. So first name will be equal to SI. S1, my bad. Last name will be equal to S2. Age will be equal to I. So now this constructor is complete, and I can invoke it now. So this is part H, okay? So I have to go to line 107 and end another line. Great. So let's call this cout This is part H. Class other constructors. Other constructors. Okay. Let's declare a new person type called person E. Okay. And in parentheses, we have to pass variables S1, S2, and I in order to invoke this specific constructor, okay? So for this new person E, what do we want to set them equal to? We already used your name, your last name, and your fake age for person C. What person do we want to put in here? Oh, here's a good idea. How about you write the first name, last name, and age of your best friend? Let's do that. I think that'll be fun. So I'm going to put my best friend here. Tyler Gall. Please don't look him up on Facebook or anything. And his age... I'm not going to put his real age. I'll just put 22. Okay. So what happens as a result of this, because I have parameters in here, line 110 invokes the constructor for with parameters string int. Okay? To prove that, I'm going to copy these lines, put them here, change D's to E's. Okay. Like that. And if I run this, you'll see that person E's name is Tyler Gall 22. Okay? Yep. So, again, 104 invoked the default constructor. 110 invoked the constructor with 3 parameters, okay? So now we are done with part H. We can do part I. Try to declare a new person type that accepts a string and a string, so a first name and a last name. And do not pass an int age into it. You'll find that it won't let you. Okay. So this is part I. Oops. I guess this is other constructors again. So maybe I'll just take that, stick it there, and declare a new person type with just 2 strings. Do not put an age. So person type person F, and let's put another person here with their first name and the last name. I'm gonna use another one of my friends. I'm gonna say Ryan Falls. Please don't Google him or Facebook search him. Okay. So what I want to do is set first name equal to Ryan, last name equal to Falls, but there's no age there. So I'm gonna try running this and see what happens. Well, after I get this, of course. Change E's to F's. Like that. As you can see, it's an error right now because no instance of constructor person type matches the argument list. But I'm going to run this anyways just to show you that it won't work. Yep, it didn't work. Now, the reason why it didn't work is because I didn't create a constructor that accepts string and string. I created a default constructor that accepts no parameters. I created a constructor that accepts all 3 parameters, but I didn't create a constructor that accepts just string and string. If I want to do that, I have to make one. Okay? Now, that's very easy to do. We're going to make another constructor prototype here. I think I'll just copy this. Put that here, delete the int because, yeah. And I'm going to copy this. The code's almost exactly the same, so cut me a break if I want to be a little bit lazy. And S1 will be first name, S2 is last name. I can't set age equal to nothing, so I'll put it to -1 again. Just cause. Okay. So, as a result of this is no longer an error. This line 116 invokes this constructor. And that's actually the last part of the lecture activity. Okay. So if I ran this, I should get Ryan falls -1. Let's see. Yep. So that's kind of it. I'm on time. Yeah. So congratulations. All of you now know what a constructor is and what it's used for. Let me take a quick minute to look at this again. Yeah. I went over everything that I wanted to go over, right? Yeah, that's everything in regards to constructors. Okay, so great. Here's what I'm going to do. I'm going to make this big so you can see it. I'm going to scroll down really slowly to make sure that you got everything. Pause it whenever you need to. I know this is lengthy, guys, but I did warn you that these next 4 weeks, they're going to be really hefty because we're going to be talking solely about classes. Okay? So, before the lecture activities weren't that bad, but now they are, because C++ is a broad subject, and there's just a lot that we have to cover. So I hope you don't mind, right? I hope that the end result here is that you guys are learning, okay? That's the one thing that I care about. And I know it's not fair pushing all this hefty work on you at the same time you're working on your take-home midterm. That was part of the reason why I wanted I wanted the midterm to be due on October 16th, so you don't have to worry about it at the same time you're worrying about lecture activity 6. But again, what can you do? Like, this class only meets once a week, and there's only so much that I can push to you guys in the span of 15 weeks, right? But yeah, this is actually it for your lecture activity. I hope you got everything. How many lines of code is this, I'm wondering? So this was almost 250 lines of code. But now you know how to make a struct. Now you know how to make a class. And that's going to be very important in the next week, because in the next week we're going to talk about inheritance, and we're going to write we're going to write 2 new classes called student type and faculty type that will inherit from person type. Yeah, I know you guys are groaning. It took 2 weeks to write this class, and then next week we're gonna write 2 more classes. Like, how many lines of code is this one class? It's 91. Yeah, it's a lot of work, but we will get through this together. So don't worry, guys. Anyways, it's time to turn this in. So here's what I'd like you to do. Run this once more. There's a lot to get a screenshot of. Let me think. Take a screenshot of this. Get as much as you can. Okay. Make a new email. Put the screenshot on the body. Send it to me. Subject CSE2000Q2S. Last name. First name. Act 6. And here's another thing. When you're submitting this assignment, I actually need 3 things from you. The first one is the screenshot. The second one is the main.cpp. The third item is the persontype.h. So you're submitting 3 things this time. So click the little paperclip item. Go to where you've saved your lecture activity 6. Go in the project folder and attach main.cpp and persontype.h. Okay. Now it's very important that you include both of these. If you're lazy and you will only include one of them, I can only give you half credit. So make sure you include both the CPP file and the .h file and send that to me. But yeah, that'll be it for lecture activity 6. Next week we will discuss inheritance, and in the meantime, at the same time I'm going to be writing the new lesson for inheritance, I'm also going to be reading all of this about the human heart. Because, yeah, master student life, you know. But wish me luck on this, guys. Hope that I don't die from this class and my other classes and my master's project. And hopefully if I'm not dead, we will continue with the lesson and talk about inheritance. So I will hopefully see you next week. Bye.